Year 2 and welcome back to your online maths lessons. I hope you all had a lovely half term and I hope you're excited for a new maths unit. So we are starting volume. So a little bit different because you don't have your maths workbooks yet, your other ones. But if you're going to do the challenge, you'll need some cups or jugs or glasses, any kind of container, and some water. And everybody will need some blank paper, a pencil, and a partner. So, our new unit of volume. I know most of you probably know that volume can mean how loud or quiet something is. So you might turn up the volume on the TV to make it sound louder, or turn down the volume on the music to make it quieter. But volume also means how much space is being taken up. So when we talk about the volume of liquid, like we're going to be doing in this unit, we're asking how much liquid is there? How much water is in the jug? How much milk is in your cup? How much paint is left in the bottle? All of these are examples of volume, how much liquid there is. We'll also be using the word capacity. Capacity means the most amount a container can hold. So the greatest volume that you could fit into a container. In this picture here, the red line is pointing to the top of that jug because capacity means how much water, how much liquid would be in there if we filled it all the way to the top. We can also talk about capacity when we're measuring things that aren't to do with liquid. So we could talk about the capacity of a classroom, maybe asking how many people can fit in a classroom, or the capacity of a pencil case, how many pencils can fit in the pencil case. But while we're talking about volume in this unit, we'll be talking about how much liquid you can fit into a container. Now, you'll find volumes and capacities everywhere, but you'll find quite a lot of them in the kitchen. So I've got a few examples here of some capacities. You can see the capacity, I'll point it out. We can't see the volume in any of these, but I'll explain a little bit about them. So if we start with the bottle of lime juice, the capacity is written here. It says 200 millilitres. That's the most amount of lime juice that can fit into that bottle. Now, when I bought it, that's how much it had, 200 millilitres of lime juice, but I've used some of it now. So their volume, how much is in there now, is less than 200 millilitres. At the start, there were 200 millilitres. I've used some, so now the volume is less because the bottle is not full. This apple juice is brand new. I haven't opened it yet. So the capacity of the carton is 1 litre. That means you can fit 1 litre of apple juice into this carton. And because I haven't used any of it, there is still 1 litre of apple juice in there. So we can say that the capacity of the carton is 1 litre and the volume is 1 litre of apple juice. The capacity of this bottle of soap is 250 millilitres. So the most amount of soap you can fit in when it's all full is 250 millilitres. Now, I filled this up during the week. So during the week there were 250 millilitres, but I've used a little bit now, you can see at the top. So the capacity of the bottle is 250 millilitres. That's the most amount of soap I can fit in. But the volume is slightly lower than 250 millilitres now. There is slightly less than 250 millilitres in this bottle. I bet if you have a look around your kitchen, you are going to find lots of different things that list the capacity of how much liquid can fit inside. And maybe you can have a look and see if you think the volume inside is the same. So don't forget, volume is how much liquid is in a container now. Capacity is how much liquid can a container hold all the way up at the top. So if you want to remember about my apple juice, when I buy it, it is full. The capacity is 1 litre and the volume is 1 litre, but then thinking about the lime juice, the capacity is always the same. It was always 200 millilitres, but I had used some of it. So it wasn't full all the way to the top anymore. The volume was less than the capacity. So today's lesson is all about comparing volumes. So I've got 3 bottles of water here now. I've changed the colour of the water to make them different colours to make it easier for us to compare them. So we've got a blue bottle, a yellow bottle, and a green tub. I want to compare how much water is in each one. Now, all of these containers are filled to the top, or as close to the top as I could get without spilling it. So what we're talking about here is the volume, but also the capacity, because they're full all the way. But my question is, which container has the most water? Which container has the greatest volume of water? You can pause the video here and have a chat to your partner, and on the next slide I'll show you how we can investigate that to measure. So some of you might have suggested that I could use a measuring jug to measure these capacities. But in all of the baking we've been doing recently, I've lost my measuring jug. But I can still measure and compare these capacities. Remember, they're capacities because they're filled all the way up to the top. Each of these containers is filled all the way up to the top. So it's their capacities we're going to measure, how much they can hold in total. How I'm going to measure and compare them is by using 3 of the same sized containers to put them in. Because it's very hard to compare when they're all such different shapes. This one is short and very wide. This one is tall and narrow. This one is sort of medium height, it's wide at the bottom and narrow at the top. So we need to put them all into the same kind of container. So the best thing I could find was some lunch boxes that I have 3 of the same of, 3 identical lunch boxes. So I'm going to pour each of the liquids, each of the volumes of liquid into each lunch box, and that will help me to compare. So I'll start off with the blue liquid and carefully pour it in. There we go, not too much splashing. Move that back, hopefully you can see it better. And the yellow liquid. Oh. Thought I was going to have some splashing there. You can see there's still a little bit at the bottom. I had to use paint to make the water coloured, so that's paint at the bottom, but that's not going to come out right now, so we'll leave it there. And finally the green one. I'm afraid this one might spill. Oh, no, very good. And again, you can see some of the paint at the bottom. You can even see which colours I used to make this one. So, leave that over there. Now that these liquids are all in the same sized container, it's much easier for us to compare them. So, we can have a look at the blue liquid, and if you look at the line that the liquid goes up to, where the liquid stops, the blue liquid doesn't come up very high. It doesn't fill much of that container, that lunchbox. The yellow one fills quite a lot of it. I'd say maybe a little bit over half of the tub. There is definitely more yellow liquid than blue liquid. And if we look at the green liquid, there is almost as much green liquid as there is yellow liquid. There is slightly more if we go up nice and close. It's hard to see because you're at an angle, but you should just about be able to see. There is ever so slightly more yellow liquid than green liquid. So it's a little bit easier to compare with this photo here on top. So we have one photo of what all the liquids looked like before in their bottles, and beside them is the photo of them poured into the identical containers, the containers that are the same size, where we can compare them. And I can make a few statements about these, a few fact sentences. I can say that the blue bottle has the least amount of liquid. I can say the yellow bottle has the most liquid. I could say that the green tub has more liquid than the blue bottle, because if you look at the picture where they're all in the lunch boxes, there's more green liquid. It goes up higher than blue liquid. Or I could say that the blue bottle has less liquid than the green tub, which is the opposite of that sentence. Now have a look at this one here. These containers aren't filled to the top, so we're only comparing volume here. We're not comparing the capacity because none of these are filled to the top. So, having a look at this picture and thinking about what we just learned from the last example, have a chat with your partner. Which container do you think has the most liquid?
Now, just like in the example before when we were comparing the capacities, it's hard to compare these volumes when they're all in containers with such different shapes. This one is kind of medium sized and medium width. This one again is short and wide. This one's quite tall and sort of medium width, but then it gets narrower at the top. And of course, this is volume. None of them are full all the way to the top. So we're not comparing their capacity, we're comparing their volume, how much liquid is in there right now. So just like before, I'm going to get out my boxes that are all the same size, they all have the same capacity, so I can put them into the same sized containers and then I can compare. So we'll start off with the yellow first. Carefully pour that in. Okay, next up we'll do the blue one. Carefully pour that one in. And finally we will do the green one. Okay, doke. So now if we put them all beside each other, we can start to compare. So again, once all the liquid has stopped moving, we can look at the line where the liquid stops, where it goes up to, and you'll be able to see that a bit clearer in the picture on the next slide.
So here we've got a picture of what all the liquids looked like in their containers at the start, and then a picture of them in the identical containers, the lunch boxes, after I've poured them in, so that it's easier for me to compare them. So again, I can say lots of different statements, lots of facts based on these pictures. I can say that the yellow bottle this time has the least amount of liquid, or the smallest volume. The green bottle has the most liquid because the green water fills the most of the identical tubs, lunch boxes. So I can say that has the greatest volume. The blue tub has more liquid than the yellow bottle. And I could also say that the blue tub has less liquid than the green bottle. And we can compare capacities just using pictures as well. It's a little bit harder than using real tubs and real liquids, but we can do it. So if we have a look at this picture of 3 glasses of green juice, we can answer the questions. Which glass contains the greatest volume of juice? Which glass contains the least volume of juice? which glass contains less juice than glass A, and which glass contains more juice than glass C. Now, I'm going to go through the answers and explain them on the next slide. If you're feeling really confident with volume so far, you could pause the video and challenge yourself to have a go at these questions with your partner. So, some answers. Which glass contains the greatest volume of juice? It's glass B. I'm going to get my little red dot up and we'll have a look at why. So, the reason glass B is the correct answer is because if we compare the three glasses and how high the green juice goes, glass B has the volume that goes up the highest. All three of these glasses are the same, so we can compare how much of them is full. And glass B, the juice fills the most of it. It goes up the highest. For the next question, which glass contains the least volume of juice? It's the opposite, really, of that first question. We're looking for which glass has the least liquid, so the line of juice goes the lowest. And that is glass C. The line, if we look at the bottom of this curved line, if I go across as straight as I can, you can see that it doesn't go anywhere near as high as in glass B. I'm trying to stay as straight as I can. In glass A, it still doesn't go as high as the green juice does there. So glass C has the least volume of juice. Which glass contains less juice than glass A? So glass A has juice up to here. If I go across, again trying to be as straight as possible, well, glass B does not have less juice than glass A because the juice goes up much higher in the glass. If I keep going across to compare glass C, yeah, glass C definitely has less juice than glass A because the juice of glass A comes up to here where my red dot is, but the juice in glass C doesn't go up that high, so there is less. And finally, which glass contains more juice than glass C? Well, we already figured out that glass C has the least amount of juice. So which glass contains more than glass C? Well, it's both glass A and glass B because their juice goes up higher than glass C. Have a look at this picture here, this diagram. We've got three different bottles, A, B, and C. Now, I want you and your partner to have a chat about these two different questions. First of all, can we compare the volumes in these bottles? Second of all, can we compare the capacities of the bottles? So remember, volume is how much liquid is in there right now, and capacity is how much liquid can go in there when it's full to the top. Pause the video here and have a chat to your partner about these two questions. Okay, so these are two quite different questions, even though they sound similar. If we understand that volume and capacity mean different things, you will realise that the answers are quite different. So, first of all, can we compare the volumes in these bottles? Well, no. We can't compare them because we don't know how much liquid is inside each bottle. We can't see how high up the liquid goes. Maybe these bottles are full right to the tippy top with water. Maybe they're empty. We just don't know. We also know from the start of the lesson that we can't compare volumes when they're in these different sized containers. We need them all to be in the same container. So if there is any liquid in them, we would need to pour them into identical containers. Right now, we cannot compare the volumes here because we don't know what the volumes are. Can we compare the capacities of the bottle? Well, yes. We can't compare them exactly, But we can estimate, that means a sensible guess, we can estimate the capacity by looking at how tall each bottle is and how wide each bottle is. And that will help us to get a good idea of how much water could fit in there if they were full. Because remember, this is asking about capacity. How much water can each one hold? We can't say anything exactly, but we can have a look and we can use our reasoning, our common sense, and say, well, you definitely couldn't fit as much water into bottle C as bottle B. And I think you could probably fit more water into bottle B than bottle A, because bottle B is taller than bottle A and it's wider. So it's time for some guided practice now. In this question here, you've been given 3 containers of water, A, B and C, and I want you to fill in the sentences underneath using the words less, more, greatest or least. Remember, this is guided practice, so I want you to work with a partner so you can just say these sentences out loud. If you want to write them down, you can, but I really just want you to get lots of practice using these words. Less, more, greatest or least. Okay, and now it is time for independent work. Independent work is slightly different today because we don't have the workbooks. So I have made these worksheets where you have 2 pages. One which asks you to compare volumes. So you have a diagram, a picture in each question, and you have to write a sentence underneath. This example is slightly different, just in terms of how the questions are numbered. But the task is the same, to write a sentence to compare the 2 containers. The second page asks you to compare 2 capacities. Now, because we don't have workbooks, I tried to make this as simple as possible because I know not everybody has a printer and not everybody wants to be printing out new paper every day. So you can just write sentences like this. You can have a look at the pictures on your tablet or your computer or your phone, and you can just write your sentences like this. Number 1, and then write your sentence to compare the containers from question 1. And if you'd like to have a go at the challenge, I suggest you do this challenge in a kitchen or a bathroom, or maybe even if you've got some outside space and the weather is nice, because it could get messy. I want you to use some cups or glasses or bottles to have a go at comparing some volumes of water yourself. You could ask yourself questions like, which of your containers has the greatest capacity? So maybe you're using a cup and a glass and an empty lunchbox like I had, and see which one has the greatest capacity, which one can hold the most water when it's full to the top. Then you could also find out which one has the least. Don't forget, if you're comparing these ones, then you will need to have some containers that are identical, that are equal. So I used my lunch boxes because I have a set of lunch boxes that are all the same size. But you could just use glasses if you have a few glasses that are the same size. You could use bowls if you have some bowls that are the same size. Just need to make sure they're all the same size for comparing. And then, can you arrange the 3 volumes of water in order from the smallest volume, so the least water, to the greatest volume, the most water? You don't have to upload this work. The work we'll be uploading will be later in the week, but if you want to upload some pictures of your work, please do. I can't wait to see it. Good luck!